I'm Mike Simpson. I'm the Director of Infrastructure Systems and Software in the Network Services Division, Internet2. Just wanted to take a few minutes and a few slides this morning and talk about the Performance Assurance Service, sort of the new version in NGI versus the older version that we've been running, how we designed it, some of the features, and a status report and what the sort of upcoming next steps are going to be. And I've talked about this in a number of other forums, but I wanted to just do a quick review of the project history. So we've always had a performance assurance service. We've had one running for a number of years. We wanted, as part of the NGI initiative, as part of the network replacement, we wanted to upgrade that, enhance it, sort of bring it up to current stats as much as possible. And there were three sorts of goals for that project. Expanded coverage. So we had limited coverage in the old PAS network. We didn't have all our points of presence covered. The new PAS will have perfSONAR test points at all 47 of our packet level points of presence. There are some POPs that are just optical only, and we didn't deploy perfSONAR there, but for anything that's got packet gear in it, we've got a node there to run perfSONAR. Increasing the bandwidth on the PAS node connectivity. So the old nodes ran at 10 gig, the new ones are 100 gig capable. And more importantly, separation of internal and external use cases. So we internally at Internet2 use the perfSONAR mesh for monitoring, alerting, internal testing of the backbone, things like that. We wanted to provide external facing, membership facing testing capabilities and try to do it in a way that we made sure that neither side can step on the other. So, right, external ad hoc testing can't trigger false positives in our alerting system, and testing we might be doing at a particular point in time wouldn't interfere with membership testing. So those are the main goals for the NGI PAS service. I want to run quickly through some architectural bits and pieces. My previous talks on this have been pretty high level, so I'm going to get a little further into the weeds on this one. So the servers they're just based on OEM Dell PowerEdge R6515s. And so we sort of picked those after looking at a number of different specifications and best practices documents. The Fiona specifications, Science DMZ, other similar recommendations for building high bandwidth appliances with commodity hardware. The 6515, we like it. It's 1U, which is great. Space is always at a premium in our POPs, and so it was nice to see how much you could pack into a 1U server. You can get them in DC power configurations, which again is ideal for POP deployment. It's a single socket AMD EPYC architecture. So the CPU variants we went with have 24 cores. AMD has simultaneous multi-threading, similar to the hyper-threading in Intel. So you wind up with 48 CPU threads visible from the OS level. And it is a NUMA architecture, and we do have these servers configured as 4 NUMA nodes per server. That I won't get that far into the weeds, but that can have a lot of effect on kind of your top end performance as you're trying to push the higher bandwidths through these. Another important factor, these servers support PCIe v4. So if you're pushing 100 gigs or multiple 100 gig streams, you really need that. They support it, I say, for one PCI slot at least. That's not, they don't make a big deal of that, but if you dig into the documentation for these servers, there's one PCI slot that'll run at v4 speeds if you put a v4 card in it. They come in a number of different chassis variants, depending on what kind of drive backplane you're looking for. We went ahead and got the ones that are the all NVMe backplanes. So you get 10 hot swap slots, you can put NVMe drives in. We're not actually using these servers for much in the way of storage or sort of high-speed storage, but we wanted to have that available to us down the road for other uses. And then these servers have a moderate amount of room. Again, they're 1U, so you can't cram everything into them, but we were able to get, on these we configure with the iDRAC port for integrated lights out management, a couple of 1 gigs embedded that's just for kind of OS access. And then we added a dual 10 gig card in the mezzanine slot, and again, the Mellanox ConnectX-5 cards for our dual 100 gig ports. These boxes have a ton of room for expansion as we've deployed them. So we only populated 2 of the 16 memory slots and 1 out of the 10 drive slots in each of these. That's all we need to run the perfSONAR test points that were sort of the focus of this project. But these boxes can and probably will in the future be expanded to serve other purposes as well. So that's at the low level of the system hardware. In terms of OS architecture, we went ahead and deployed with, you're going to deploy on Linux. We picked Alma Linux, which is just a Red Hat Enterprise Linux clone. It's the one that's made by the Cloud Linux folks. They advertise it as a one-to-one binary compatible fork of Red Hat Enterprise Linux. This distribution was part of a number of distributions that popped up after Red Hat discontinued support for the CentOS stable distribution last year. There were a number of community members in the Linux community that thought that opened up a gap that needed to be filled. We could have used, there's a number of them now. We could have used Oracle Linux. We could have used Rocky Linux. We went with Alma just because of timing. They had their installation media out of beta a little ahead of the rest. But it's, as an old Red Hat sysadmin, it's just like running Red Hat Enterprise Linux. I haven't noticed any particular differences as we're getting the boxes set up. And you could drop in Rocky or Oracle. It wouldn't make any difference to the design, I think. For deployment, because we have a large number of these servers, 47 of them across the United States. One of the nice features of the iDRACs that ship with these is you can do remote media mounts. So you can point to an ISO that's living at any URL that the box can see, and you can treat it as a local CD drive. That combined with Kickstart configuration, which is just a way of all of the fields and picks that you normally do in the installer sessions, you can put them in a config file in this Kickstart format. And then the process of installing a box really becomes, you boot off the installation media, and then you tell it where the Kickstart file lives, and it starts the install, and you go get coffee, and 5 or 10 minutes later, you reboot the box and you're up and running. You can get even faster than that. They have some Pixie capabilities on these boxes that we didn't use, but it was really nice to be able to, again, sitting in my office at home, to get 5 or 10 console windows up through the iDRACs and do big parallel installs that largely took care of themselves. At the OS level, it's a very minimalist installation, as little as I could get away with. We wanted to minimize the attack surface, the complexity and the maintenance requirements for that OS layer. Any kind of complexity or customization or service-specific installations, the intention is always to keep that at the container level, not at the OS level, so the OS stays really clean and simple and easy to maintain. And the containers are where all the complexity lives. The only thing we did beyond that minimal Red Hat install was to configure some of the usual services, DNS, NTP, LLDP. We added on the Mellanox drivers and utilities that you need for those Mellanox cards to work correctly. And we did go with Docker Community Edition. Docker CE is what we're using for our container environment. Again, at that level, there are a bunch of different products now, like Podman is the Red Hat product. There's a number of drop-in replacements for the original Docker software that we could have used. It wouldn't make any difference to the way the boxes are configured to run, really. Docker CE was, again, just well-known, well-supported. It's got a good history, so we went with that for the initial rollout. And on these boxes, I should say that the real time spent on these was all in the post-install tuning. And again, you go back to those Fiona documents and the best practices for building 100 gig commodity boxes. We've spent a lot of time trying to come up with ideal tuning configurations to get as much performance out of these boxes as we can. We have a long way to go. I'd say we're at a good sort of starting point in terms of OS tuning and customization, but I think we could probably get it even better as we sort of run these boxes and get more used to them. So then up above the OS, again, this is where we're trying to contain the complexity. Each of these servers runs multiple perfSONAR containers, 2 or more, depending on what kind of a POP it's in. And again, the goal here was to get as much isolation between each of those perfSONAR containers as we could possibly maintain, make sure they can't really step on each other as they're running. So in Docker, we use something called the MAC VLAN networking. Without getting too far into the weeds, that's basically as close to directly connecting a container to the network as you can get. And it's an easy way of isolating a specific container to a specific hardware port and making sure that all the packets you're guaranteed are coming in and out of that specific port. We also, when we deploy the containers, Docker has some capability of locking your containers to specific CPU cores, memory allocations. We lock out all the swapping. Again, just trying to make sure that these containers can run in isolation and not interfere with each other as much as possible. The container images we're using are just the perfSONAR test points. The perfSONAR project has been producing containerized images of their software for quite a while now, and we're just using the ones that they publish with very minimal modification. We did something just to point out as we're talking about this. We did, out of a sense of hopefulness, allocate both IPv4 and IPv6 addresses for all of these containers and all of these test points. We used point-to-points, so /31s and /126s subnets to kind of minimize the IP space we were taking up. And that did require some local patching to Docker Community Edition. Docker CE out of the box does not support /31 point-to-points because it was written by software developers and not network engineers. And so we had to do, there's a small patch that we put into the code to support the /31s. That patch has actually now been accepted by the Docker CE folks, and it should be in the next major release. So that having to maintain that little local patch fork is hopefully not going to extend for more than a couple more months. If you look at the diagram on the right, that's just to show this is our El Paso point of presence, which I picked because it's moderately complex. It's neither the simplest nor the most complex of our installations, and it's near where I live. So, and you can see that Dell R6515, the iTrack port and one of the 1 gigs is connected only to the SMN, to our out-of-band secure management network. And so that's actually the only way you can get to the OS level on the box is through the SMN. SSH does not, it only listens to the port on the secure management network. So again, trying to keep that OS layer well secured and as simple as we can make it. And then on each of the NICs that we're using, we build a MAC VLAN construct. So that's that networking construct I talked about. And then we put a perfSONAR test point on top of that construct. The 100 gigs always go to the sort of first device in the POP, so Core 1 or AG1 in most of our POPs. And then if there's additional devices in a POP, since we're in a sort of a disaggregated network now, we'll connect those 10 gigs to those other devices so that we've got testing paths that run through the other devices in the POP. Where are we at now and what's coming up next? So the full deployment as originally planned is 47 nodes. I've got essentially 40 of those up and running now. 3 of them are offline because we had some power and space issues in various points of presence that are still being resolved. So those are sitting in boxes, but they should be up pretty quickly. And then I had to take 1 node and I repurposed it for installation support. So again, these boxes are largely isolated from the outside world until you install the containers. So to do the OS installations and things, that's all through the secure management network. And I needed kind of a point within the SMN where I could put installation media and packages and things like that. One of the problems we ran into, and one of the things that's kind of delayed this rollout, we initially deployed these using 100 gig DACs, direct attached copper cables for the 100 gig connections. That turned out to be highly problematic for us for various reasons. We just couldn't get any kind of consistency out of those 100 gig DACs. Literally, unplug it and reseat it, same cable in the same port, and 50-50 chance it would come back each time you reseated it. So we went back and we've now gone through all the nodes and we're replacing those DACs with AOC cables. That seems to be giving us, it is giving us a lot more reliability. The error rates, we were getting high error rates on the DACs. Those just go away when you swap out for AOCs. We don't have the problems with stability of the connectivity and the links. So again, just a recommendation, if you're deploying 100 gig stuff, I would avoid the DACs right now. In my experience, they're not particularly reliable. So we got 3 nodes where we replaced most of those cables. There's 3 where we still have to do a cable replacement. And then there's some miscellaneous cleanup pending. There's a couple of spots where cables got run incorrectly by the installers. So we're just cleaning that up as we go. But we should have all of this done and everything up and running by the end of this month, so that by the end of this year, that full deployment is 47 nodes and 76 total containers, test point containers running across those 47 nodes. And you can see we've started that little screen capture I did on the right. We started building out that mesh already. You can see there were a couple of servers that were down when I took this screenshot. So that opens up the possibility of what comes next after we get our internal testing and monitoring and alerting all finished out. And I want to get into that as early in 2022 as we can possibly do it. And my sort of notional plan for this is select some early adopters, some folks who are interested in the fact that we will now be running public-facing perfSONAR test points and who have good ideas for what we might do with those. work with those early adopters to design a service offering, sort of what's the minimum viable product, what are the sort of, what's the first few needs we could meet, prototype that implementation, roll it out to the early adopters so they can kick the tires and see if we got it right, iterate a couple times on it until we feel like it's a good, stable service and it's meeting the needs and doing what people want it to do, and then do a full rollout of that, where the full rollout for the public side is 47 test points, 47 perfSONAR containers, one on each of those 47 nodes across the NGI network. The other thing that's come up in a couple of conversations as I've been talking with folks who are kind of raising their hands to be early adopters is the possibility of doing a workshop. I'd love to do it in 2022. It's highly dependent on people's willingness to travel and all of that. So, but a number of us have talked about how great it would be to just get everybody physically together for a couple of days. Anybody who's doing this kind of implementation of perfSONAR nodes, and just trade war stories and tips and tricks and architectures and sort of start to build a little bit of a community there around that knowledge. So all of that hopefully starting up in early 2022. Again, getting people physically together is not under my control right now, unfortunately. So that's the quick summary of where we're at with the PaaS stuff. And we can certainly do questions now. I put my email address and my Slack handle on the Internet2 Slack up there as well. I'm always happy if you have any questions or no matter how abstract or how detailed, please get in touch. I love talking about this stuff. So any questions you have, I'm happy to answer. And with that, I'll stop my share.
So we've got a few minutes before breaks. We actually have time for questions for any of our presenters this morning. I know there's been some active questions in the chat, but if you have any questions, you can unmute your mic and ask any of our presenters, or if you want to ask Mike anything of his most recent presentation, feel free. I'll give folks a minute or two to unmute if they like.
Answer Steve Wallace's question in the chat.
And that was to Mike, I believe, right? Based on the time. Yes, to you, Mike. So Mike, the question was, where do you get the time for the latency measurements?
Steve, can you give me more context on that? Are you talking about like NTP or?
Yes, he's talking about
yes. Yeah. So all of these servers are taking their time off of a, I'm going to forget which tier it is. I think it's a tier 2 NTP service that Internet2, our internal IT group, TSG, runs a set of NTP servers, one of which is one of the whatever higher tiers, one of the more authoritative ones. And so all of we have access, again, the secure management network, that out-of-band network, has one small hole poked in it to let it talk to those NTP servers. And all of the PaaS nodes are all locked to that at the OS level. And then the containers are getting their timestamps off the hardware clocks in the OS. Steve, did I answer the question? Cool. Let's see. I see yeah, it will be. The jitter will in fact be interesting. Ballpark dollar figure on those R6515s as populated. Let me think. I want to say they were under 10K each. They were like around somewhere between 8 and 10K. I can't remember the exact number, but again, for a server like this, I was actually not displeased with it. I thought it was a pretty good price. And again, you can play all sorts of games with what kind of DIMMs you put in and what kind of chassis you want to move that price up or down, depending on how much performance you want to see out of them. But yeah, I think the choice to go with all NVMe was both because I wanted to future-proof. I wanted to make sure that if we found sort of high IO needs that we wanted to put on these boxes, we were able to handle those. And also because NVMe has actually come down a lot in price. It's not untouchable like it was 5 or 10 years or 5 years ago. So we went with that NVMe chassis. It also minimizes the moving parts in the chassis, again, because these are all remote devices. So to swap a SATA drive or something means sending somebody out to a POP. So I wanted to avoid that as much as possible.
Michael Lambert's asking if the recent Docker licensing changes impact the use of CE.
Yeah, it might. I think the fine print of that is above my pay grade. But like I said, the good news is there are a number of other just absolute, you drop in replacements, no extra work needed for that actual capital D Docker distribution. Podman is the one I've been looking at recently. Like if we had to switch out, I'd probably just pick that off the top of my head, since it's another Red Hat managed product, and we're using a Red Hat based operating system. So I expect that would be an easy swap to make.
So Mike, I'm sure you covered this in your presentation, but you might have kind of flown by it. Can you talk a little bit about the difference in the architecture of this version of the PaaS, where there seems to be more capacity reserved for the community to use, and then separate capacity for Internet2 itself to use?
Yeah, that was one of the key design goals, to make sure that we had at a minimum 100 gig link dedicated to internal use and a 100 gig link dedicated to community use, and making sure that those don't step on each other as best we can control it. And I think we're in a pretty good spot for that. It feels like we're getting the isolation that we're looking for. The key thing, and again, this is way down in the weeds, but locking the containers to specific NICs and specific CPU cores is really the trick. And you have to get, for some of the stuff, you have to get a little fancy. The containerization helps you there. It's actually easier to lock to specific cores, or I find it easier. It's just switches you throw when you start up the container. But yeah, so again, I think the key in the service offering now, as we again move into 2022, when we look at sort of the member facing services that are on this, is a couple of different things. What's the level of access, and what's the kinds of access and the kinds of testing that the community wants to do, and how do we organize it so that one community member's tests don't interfere with a different community member's tests? That's one thing we'll have to try to figure out. And then again, just verifying that there's nothing that we can do with these public-facing perfSONAR nodes that could interfere with the overall operation of the network. Because again, you've got 47 of them. Nominally, they can each push close to 100 gigs. You could saturate things pretty quickly if you tried hard. So we'll have to figure out. And perfSONAR has a lot of nice. It has a limits file that controls who can do what tests and what bandwidths you can run and things like that. We'll have to figure out what a good configuration for that is, to make sure that we're again allowing folks to do what they would like to do in a way that doesn't interfere with each other or with the core operation of the network.
Thanks, Mike.
Yep. Let's see. Can you split ports on one card between containers? Yeah. So you can. You split. The Mac VLAN construct splits at the device level, and so those Mellanox 100 gigs, those dual port 100 gigs, show up as two devices to Linux, and so we can split there. The question of, is there shared hardware on those cards where those 100 gig streams, even though they're going out completely separate ports, might be interfering with each other? We have yet to answer that question. I suspect I might have seen a couple of spots where that's happening. But I think we can do some tuning to get around that. And then I have in my back pocket a support call with the Mellanox folks to talk about their hardware and their drivers if we really need to get way down in the weeds and figure out how to keep that from happening.
It looks like the questions are slowing down. Any other questions? Again, not just for Mike, for any of our presenters today? Well, that was a lot of information and a lot of great input from the community. It's great to see all this activity happening and know what tools are out there and capabilities are out there for people to take advantage of. We've got a little bit of extra time, 4 extra minutes, so we're going to go right into a break. We're going to, of course, have our robot races happening while we're on break, and we'll see you all back here at 1:25 Eastern time.